video, I understand I wasn't a little bit clear with some of my explanation at the very end of the video, where I was trying to rush through some of the explanation. But what I'm going to do now in this video is try to distill some of that idea with a little bit more clarity. So one of the things we learned from the last video was that when the loop terminates, there are three possibilities that might exist. So these three possibilities are listed here as number 1, 2, and 3, and I've just used a little bit of color coding here to represent that this is the scenario, or if I were to map it with my color, is this third scenario, is a scenario when I next and j next are both actually equal to none. The second scenario is this code in blue here, which tells me that if I next is none, right? And the third scenario here is in this green here, which tells me what if j next is actually equal to none here. So again, this piece in yellow handles this piece right there. This piece in blue is handled by that scenario on my truth table, and finally this green piece handles this specific scenario of my truth table here. Okay, and now that I understand what are these three things doing here, let's just take an example. Let's just take an example for the scenario or for a use case where I next will actually be equal to none. This is one possible use case here, where I've got my first linked list containing the nodes 1 and 2. I've got my second linked list containing the node 3, 4, 5, and 6. And let's first understand what is it that the body of this loop is going to do. Now I know that the body of the loop is going to run until I next becomes equal to none. Okay, so when I next equals to none, right, I'm going to have my reference I pointing over there, and I next is going to be pointing at none, because when I next points at none, this loop terminates. And when the loop terminates, and with this use case, this is the piece that's going to execute, right? And just to be clear here, j at that time would be pointing over there, and j next would be pointing at the node 5 just when the loop terminates. Now what would my references look like? Now my references at that time, because of the merge, this orange, I won't be having the this reference, the next reference of the node 1 pointing at 2, but instead it's going to be pointing at this node with the element 3, right? And the next of the node with the element 3 would be pointing at the node with the element 2. Okay, and this is a point when the loop actually breaks, when the loop actually terminates. And if the loop has terminated at this point, what is it that the next piece remains? The next piece remains here is that if I next is none here, what I need to do then is make I dot next equals to j. I'm saying I dot next equals to j here. If this entire thing is I here, I dot next equals to j, so I'm going to have now I dot next should equal to wherever j is pointing at. This is what this piece does. And then I'm just going to say return head 1. What is head 1 here? Head 1 in this case is being referred to this node with the element 1, which points at the node with the element 3, which then points at the node with the element 2, which in return points at the node with the element 4, which in turn then points at 5 and 6. And that's exactly what the shuffle merge is supposed to do. This is the typical representation of what shuffle merge would do when you have this piece in blue executing. Let's look at a second use case when j next is none. When j next is none, this is that use case. This is the use case that I would be playing with. So again, I've got head 1, which is now a slightly longer linked list in comparison with head 2. I've got the nodes 3, 4, 5, and 6, and I've got my second linked list head to with the nodes 1 and 2. Okay, so what's going to happen at this point here? At this point, when this loop terminates, I'm going to have j next equal to none. So for j next to be equal to none here, let's first just get this completed here. So this is none. This over here is none, and I'm going to have my j next. I'm just using my loop invariant. My loop invariant here tells me that when the loop breaks, j next should be equal to none. Okay, that's right. At this point, j next equals to none. J is pointing 1 before that, so j is pointing at this node with the element 2. I at that point would be pointing at the node with the element 4, and I next should be pointing at the node with the element 5. Okay, and what would the body of the loop would have done at that point? The body of the loop at that point would have done this. Okay, the next of the node with the element 3 should be pointing at the node with the element 1, and this in turn should be pointing at the node with the element 4. Okay, so with this picture here, with this picture that I have so far, that the body of the loop would have already done for you, what is the next piece here? The next piece here is I should say I dot next should equal to j. Okay, if this is I dot next should equal to j. Let's get that piece done here. I dot next equals to j, and then I need j dot next equals to I next. If this is j dot next, this piece over is j dot next. J dot next should equal to I next. So j dot next should equal to I next there, right? And at that point, I can just say return head 1. I can just return head 1 because the linked list represented by the head node head 1 is that linked list that has been completely shuffle merged here. Okay, so I can see the 3, 1, 4, 2, 5, 6, right? And this is a use case with the piece of the code in green. Okay, so again, just as a recap, what I've done here is I'm using my loop invariant to formulate the code that I've presented here. This code is of course not complete yet. I'm still missing my initialization of my I next and j next. What is it that needs to be initialized just before the loop here? And but again, just from loop invariant, what I know is that just before the loop executes, right? The loop invariant, whatever the loop invariant must hold, my loop invariant at this point must be true just after the body, just before the body of the loop, and just after the while statement. This is the other place where my loop invariant must hold, and just after the loop terminates and before the start of these conditional statements. That's the third place where my loop invariant must hold. Okay, so and of course taking these various points, I'm now going to present finally in my next video, which is going to be the last video on this shuffle merge algorithm, where I'm going to show you the actual code in PyCharm.